So, thank you for waiting. I'm not going to lie, for 4:20 p.m. on a sunny day in Berlin in a beer garden, everyone looks remarkably sober, so kudos to you. Thanks for sticking with it. Thanks to Prisma as well for inviting us to speak here. And the longer I've been listening here today, the more it's dawning on me that almost my entire talk is going to be preaching to the choir here. And the more I feel like I should have just done a talk about hundreds of ways that MySQL is clearly better than MongoDB, just to add a little drama or suspense, but I'm not going to do that today. I'm going to keep it clean. So my name is Liz. I work at PlanetScale. It's the company that builds PlanetScale. We're a cloud database as a service. We build on top of MySQL and Vitess. Vitess is an open source middleware layer that lives on top of MySQL, and it allows for things like transparent sharding, but it also just really robustly manages and automates MySQL at really large scales. It's used by a pretty large community of enterprise users. There are contributors to it as well. It's an open source project. And they use it primarily to help their databases accomplish massive scale. But it's got a lot of benefits that it can offer at small scales as well. And as of right now, every PlanetScale user is a Vitess user, whether their databases are 50 megabytes or 50 terabytes. We launched an early beta of that platform just over 1 year ago. We've been GA since last November, and we're really just barely getting started. As a company, I would describe us as pragmatists. We're builders ourselves. We eat our own dog food. We build PlanetScale on top of PlanetScale. And really, we're just building the product we've always wanted to exist. So from my side, personally, I'm not a developer. And actually, I can code, but I'm one of those people for who it's just really a vehicle for laziness. And the reason I'm here is, well, I'll admit I thought I would have a slightly different perspective to offer based on my particular experience. So prior to working at PlanetScale, I spent about a decade in professional services in MySQL. I've worn a lot of hats in that area. But yeah, pretty much my entire career has been spent sort of working in the MySQL ecosystem, helping people try and solve problems around scale. At PlanetScale, I am a solution architect, and I would describe my day job kind of composed of technology, speed dating, and firefighting, more or less. So where does that experience and my perspective come from? So data is really the beating heart of most businesses. I don't need to tell you that. It tends to be a company's most critical business asset, and for a lot of companies, just losing it means instant death. There's just no coming back from it. So I don't need to tell anyone this, but I just want you to bear with me because I'm trying to paint the landscape and open up the perspective on this beyond just us engineers. I mean, GitHub going down for a day, even a week, pretty annoying, like slows everything down, very, very frustrating. Everyone's going to complain to each other, but most companies can probably survive that. Phone systems die, same thing, like we figure out alternate solutions. But a perfectly healthy business that suddenly loses all of their data, boom, everyone's done. Everyone goes home. And so people get really sensitive about this stuff. And they're also very strangely territorial, probably rightfully so. And 99% of incoming requests, or like the kinds of people that come talk to me, tend to fall into two main buckets. Those are the buckets. I would say I love category one. They're my favorite. They usually come in with massive ideas. They're going to change the world. They just know they're going to need to scale 100x in the first 6 months, and they want to be prepared for that. I love them. And they take up maybe 10% of my time. The other 190% of my time goes to category two. And these are the people that had an incredible business idea a while ago, and the idea worked out way too good, like way better than they planned for. And now they're just hitting instance limits, they're getting downtime, and really they just need help now. And so those end up being the cases that I deal with on a day-to-day basis. Now, just as an aside, Planet Scale talks a lot about offering sharding. We do offer sharding, but the percentage of cases where sharding is actually needed to solve a performance problem is really remarkably low. So most scalability problems that I encounter tend to be bad database design problems. And so that's where we need to address the issue. Basically, I've seen a lot of people do really bad things to databases. I cannot unsee them sharing my trauma with our engineering team, and then now also unsuspecting beer garden visitors. It feels like therapy. It feels kind of good. So that's what I'm going to do. This is the overview of my talk. I'm sort of halfway into the first point right now. I'm going to be sharing a couple of anecdotes that summarize a couple of the learnings that I've had. I believe you'll find they're echoing things that we've already heard today. I promise I haven't spoken to anyone in advance, but as it turns out, on both sides of this pipeline, like we're seeing the same things. Now, some of the things I share are immediately applicable in some cases, and I'd love to see you like open your computers and just double check if those things aren't applying to you today. And some of them are going to be a bit more conceptual. But I will share Planet Scale's philosophy around them. I do believe that a lot of it is also just common sense, and they will apply across different database platforms. So to frame this a little bit more, so not being a developer myself, the history of how databases have evolved over the past 30 years and why you could really fill libraries. So I'm going to start with a slightly different story. And I heard some other speakers sort of share their origin stories originally as well, so it's going to fit right in. 2004 was the year that I first went to college. Feel free to calculate that backwards if you must. But I always knew exactly what I wanted to be when I grew up, and I got an applied computer science degree at a small Belgian university, and it got like a healthy mix of modern programming languages. And I took note, I had a very different introduction to programming than Delba did, who spoke earlier today about Vercel. But yeah, basically, we spent an entire semester learning ASP.NET, another entire semester dedicated to learning about Jakarta server faces. Clearly, these were the web development frameworks, languages of the future. We didn't refer to it quite as nicely. We used a much less appetizing name because that's what grown-ups do. And honestly, JavaScript was kind of a footnote. I mean, it was merged in like in the same like trimester with basic HTML and CSS skills. It's not really worth spending a lot of time on, really. It wasn't even really a programming language at all. Like, it just didn't really count for anything. And so, what happened? Like, something clearly changed. So what did happen? I mean, other than, say, 2 decades of blood, sweat, and tears? And as I was thinking about this, I realized back then a text editor and a browser were already available on every single computer. As it turns out, a well-placed console.log was enough to teach millions of people back then just enough about how to build things that worked. And what we find is when tools stop getting in the way of people trying to create things, the infrastructure they need is going to follow to support them. And it just doesn't work the other way around. You can't really force people into a very, very complex system. It has to be developer-driven. And as long as there is no lag sort of on iterating and improving, developers don't seem to mind getting it wrong a million times, even over multiple decades. You just keep building until you do get it right. And that's kind of that pendulum swing that we've heard being talked about earlier today as well. Like, it doesn't matter. Like, it sounds like we're trying to build the same thing, but we are in this place where, yeah, we're getting closer. We're really getting closer. So that is how mountains get moved. And that is the kind of energy that's driving Planet Scale. And we want to do everything we can to keep that momentum going. So the energy, which I'll nickname the unstoppable force, has a tendency to smash into what I'll call the immovable object, which is business data requirements. Super pain in the ass. So needing to think about how you're going to structure your data while you're still just barely prototyping is a super pain. And let's be honest, it gets even harder further down the line, even when your core functionality has already been fleshed out, because a database is often really a reflection of a much broader business process than just the stuff you're thinking of while you're making those first baby steps. And the burden of balancing all of that while you're excitedly trying to build something new is just too much of a burden. So the responsibility here also ends up being really fuzzy. And because schema changes for relational databases have been really hard, it ends up feeling like you're locking yourself into certain mistakes right from the start. And there's no arguments here from me on that side. Like, I know this is hard. I mean, these things are difficult. But we do know that all successful product companies eventually manage this process in some way. Nearly all of them eventually end up diving straight into the fun bits, which is just trying to manage this insane smorgasbord of data they've started collecting to actually get to the information that's locked within. And don't even get me started on the infrastructure side of it all. I heard Kubernetes being brought up previously. I've been using it almost daily for 3 years, and I've been solving problems in it on a daily basis. And every time I use it, I'm more convinced that computers were just a mistake. Like, we just shouldn't. This is too much. So it is a nightmare. It's really a lot. And so this is kind of where our stories come together. So where the database world also got really interesting is around the same time when JavaScript kind of refused to die. And in addition to schemas being really hard, traditional relational database solutions were just too expensive. They didn't really keep up with like this rapid shift to cloud infrastructure. I mean, MySQL was 15 years old around that time, and it still struggled to adapt. Like, it just couldn't keep up, so something had to give, and Shazam! Suddenly we've got all these single-purpose databases popping up everywhere. We got in-memory stores, we got databases that completely change the format in which data is stored to allow for flexibility while building. We've got like unicorn companies of the Web 2.0 that are just trying to adjust to a tidal wave of data that they suddenly need to process. And everyone's going off to solve their unique challenges. And so builders now have this endlessly diverse box of database Lego blocks to choose from, combined with a massive world of new development principles. But the majority of businesses still just need the same thing, and it's the same thing that they needed 20 years ago. And the solutions that are still around today after that sort of burst, lots of them have started converging on similar sets of features. And you now see MongoDB supports transactions, and actually they do have a schema, et cetera, et cetera. But like, these initial principles on which they were built didn't include that. Turns out that's what everyone needs, though. So over all of those years, none of those companies stopped getting better at it. Like, they're all getting better at it. And there was one other quote that I picked up today that Delva said that I think summarizes the journey really well, which is that, like, we got to look at it as builders versus cynics. Like, it doesn't matter. Like, it makes sense we're all converging on the same place. It makes sense that we're all trying to offer the same feature. It's the same problem we're trying to solve. So here's the magical wish list. Pretty much the same for every single business I've talked to. People need a stable data model just so they can turn things into business intelligence. Everyone wants some consistency guarantee at some point, at least some of the time. And everyone wants to be able to scale 100x just in case they need it. And ideally, they never have to worry about availability either. So really, like, that's what people want. So, I mean, if you're like experiencing a bit of deja vu, please direct the blame at whoever scheduled me late in the day. It's definitely cooler to be quoted than to realize you pretty much wrote the same presentation as many other people. But it's honestly also been kind of amazing how solutions that are living in all different layers of the stack are sort of addressing the same underlying problem. And at least we're all looking in the same direction now. So what ORMs like Prisma can do is so much to bring us closer to finding that sweet spot of combination, like sweet spot combination of technologies that just lets us finally overcome the business challenge of having this stateful data store. And at Planet Scale, we're also aiming to set a new standard for what people expect from their databases moving forward. And we like to use a quote there, think not of what you can do for the database, but what the database can do for you. So I made a small fix to the screenshot from the, I don't agree with the fact that databases have to be brittle, but look, everything else in there is fine. I'm not sure if that's really readable. It looks really dark. But I wanted to add a little transparency check. You might be thinking, who's this woman talking at us about building product? And she just said she can barely code her way out of a reserved linked list, a reverse linked list, or whatever that is. Really, who knows? You're right. I don't know what it is. And I've learned everything I know from just observing and addressing other people's pain. And from listening as well to the people who've done this at some of the biggest data companies in the world. Now, there was another talk, and there are so many points today that I thought, oh my God, like, we should have talked up front. But I believe it was Hassan who spoke earlier, described kind of the cycle that I've tried to outline in this graph. And what I call solving for scale was sort of step 4 in the process, in the life cycle that he described. And I stole this diagram from my CEO. He used to be the VP of engineering at a company called GitHub. If that's not enough clout, our founding CTO is the person who built Vitesse while he was managing databases at YouTube. My boss was a DBA at Twitter. In our engineering team, we've got people who build core infrastructure at Instagram, at Facebook. And like, seriously, some of these people have forgotten more about scaling databases than most of us will ever learn. So it's just, there's an incredible amount of knowledge gathered around us. And if you don't want to take it from me, take it from them. Like, every company goes through cycles like this. And if they're lucky, they only get stuck in the solving for scale phase once. If they're really unlucky, then they never really leave that red zone, and eventually they end up talking to me to try and pull them out. So, yeah, my punchline for the talk has already been leaked. It doesn't hurt to repeat it one more time. This was going to be sort of the basis of this talk. And when Søren, who I've never met before, mentioned almost this exact same sentence in the keynote, I'm sure like someone must have heard my forehead slap. Again, though, I think it's really kind of beautiful that the problem has a recognizable name and everyone is trying to solve it. So let's talk about a couple of scenarios that are one and all made more complex because of this simple fact that state has weight. And that state, like any operation that you're trying to do in a stateful environment, ends up costing more. So I work with a lot of different companies, most of which I'm actually not allowed to call out by name. So I've just grabbed an example that I actually had zero direct involvement in myself, but whose story is just sort of out there on the internet, and it's a very sobering example. Imagine it's early 2020, Slack is happily experiencing the sort of healthy growth that's already forced them to rethink their scaling strategy. So at this stage, they were already shifting into Vitesse. They redesigned what they wanted their environment to look like. They just weren't quite there yet. So they were actively contributing, but they were migrating at a bit of a leisurely pace. So they were in a better place than most. But then COVID happened. And every single company that was already stretching that old model of theirs suddenly increased their usage of Slack something like 10x overnight. So just try and put yourself and your application in that position, and you can imagine just the heroic effort that followed. They've written extensively about it in a blog and on Twitter, so I'm not even going to go into the specific details here, but I'm just going to summarize a couple of takeaways. So these past 3 years have been like an unexpected mess in a lot of different ways to a lot of people. There's just been world-shattering events happening like one after another. And in this case, Slack was able to ride that wave because they were sort of prepared, but how many companies ended up just leaving massive piles of money on the table, or even worse, just kind of had to buckle under the pressure of a completely changed workload because they were basically caught with their pants down. So if you don't want to think about how you're going to scale your data right from the start, fine. But don't leave it until step 4. Don't create this separate stage in your company lifecycle where you're going to deal with scale. That is just not how it's going to work. So whatever it is that you need to do, if you want to outsource your knowledge gaps by going serverless, I mean, we'd love that. But honestly, like, go nuts, build your own. You wouldn't be the first. You're not going to be the last. Just start as early as possible. Start to think about this problem. And I guess the main thing I can say is, like, you're no longer alone in this. So many other companies have had to deal with this. Your problems are not unique, and they've probably been solved before. And talking about them with either experts or just with your peers are going to dramatically help avoid the biggest kind of drama. So, second anecdote. YOLO schema design choices. This is one that's a little bit more specific. So it's the kind of stuff that we can see people run into almost every single day. Somehow, they still end up blindsiding companies right in the middle of, like, a blissful growth stage. From one day to the next, like, they're just cruising along nicely, and the next day, like, their database is down, and they've got, like, they can't figure out how to fix it. So I'm directing this anecdote to anyone at Prisma as much as other developers here. Because for all the talk that I heard today about type-safe ORMs, and I know it means a different thing, but it always sort of reminds me of this. I'm not really sure why SQL data types are considered safe themselves. Like, they're just, it's just as easy to shoot yourself in the foot with these supposed standards that everyone adheres to. So who knows the importance of the number on my slide? I don't know if you can read it, but it's 2,147,483,647. I'm hearing some vague, like, signed and that's about right. So it's the maximum value that you can store in a signed SQL standard integer type before its binary representation on disk starts overflowing, and basically you've spent all the space that's been allocated for it. So that means you can still try adding higher values, but there's just no room to store that, and you're kind of stuck out of luck. So that, like, if you combine that sort of situation with the primary use case, I think, of auto-increment columns across databases, which is to create a primary key. Every single one of those values is already used. It's a quietly ticking time bomb. And if you go online and search for people like this specific number, you know that people have run into this so many times. It happens all the time. This is not a new problem, and yet everyone still just creates their tables with ID int auto increment, and they never think to go back to it. And so very, very often, this is the kind of problem that we run into. It's very debilitating when you actually run into it. When it brings you down, it's usually in a case where your database is already significant sized. It's under heavy load. Trying to fix that, pairing that with, really expensive schema changes, is hard. Don't do it. Don't be these people. So just to give, rather than have you all run off to MongoDB, I just want to give a little context around why this happens and why it's still worth it. So predefined column sizes are at the heart of what make relational databases fly, specifically on these structured OLTP workloads. It just becomes super, super easy with a well-defined schema and ultra fast to tell your SSDs to grab just those bits that you need and never even bother looking at anywhere else. So it's that fast because the database engine just wastes no microseconds at all, even thinking about how it could read something from disk or memory. It just knows because you told it. That's your schema. That's why you define that schema. And it's a very simple and elegant thing that people tend to forget about. But this is also why it exists. And this is why relational databases are fast at these types of workloads. But yeah, using words like type safe, this is, again, something more generally directed. Maybe that's something Prisma can help resolve. I included a little screenshot of Prisma's int type mapping to the various databases that they support in their documentation. And I think, what is it, like 6 different types of databases are in there. So can you guess how many of those databases will run into exactly the same problem by doing exactly what they're told? It's all of them, because this is an SQL standard. Like this is, I mean, it's working as designed, which is tragic and really, really stupid, but it still happens. And so using an ORM doesn't really mean that you get to just forget about what's running underneath. And, well, I just want to say, break the cycle. Don't do this. And if Prisma can do anything about this, like I would say ORMs have kind of been offending recommended database practices for decades. So at this stage, like, if this is not something you can protect people from shooting themselves in the foot, as a good general default, it would just, it would just go such a long way to help people avoid these problems. So it's a different kind of type safeness, but it would help a lot. All right, number 3. This anecdote is kind of at the heart of what our CEO desperately wanted to solve for after his time at GitHub. And we think it really is key to rolling with the punches and not letting your development cycle stall while you are solving scalability problems in reverse, or in parallel, as it were. So I'm not going to pretend PlanetScale offers the only answer to this. Prisma offers migrations, like quite a few other development frameworks offer similar implementations that are kind of variations on the same theme. Most of them offer one way or another to at least streamline database changes alongside your code changes, making sure one team of developers isn't dropping columns others need for features being built in parallel, blah, 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 blah. So it sort of codifies database changes into a growing history of your application development and makes those, it orders them in deterministic ways. It makes it easy for people to reproduce replicas, helps them understand what the status of their staging environment. Like, it compares everything. It just introduces the database into this workflow in a way that's never been done, and that's amazing. It's a really, really, really good solution. But here's where we often bump into the next level of the problem. And again, this is related to the weight of the data and how impactful schema changes can be on a large and busy system. And that's a challenge that can't really be transparently handled by an ORM alone. So PlanetScale relies on its internals to figure out the best possible way to consolidate a production schema with the changes you're trying to roll out. In some cases, that might mean it's actually going to rewrite your alter statements because it doesn't agree that the way you're trying to accomplish something is the most effective way, or is the way that's going to have the smallest impact. So it treats DDL statements as deterministic, and it executes them in a completely non-blocking way as well. And if you don't trust me on that, no worries. We also allow you to rewind and revert those changes instantly. So once you have a schema change applied, you can just switch back and forth. We keep 2 copies of your table there. You can try both versions. If you need to roll back your code, that also remains available. So that's kind of the additional piece that we see as really critical to closing that loop. And to us, what we were trying to accomplish with that, I put these 2 diagrams next to each other. On the left-hand side, it's sort of what the general Git pull request workflow looks like. And we wanted to design a database experience that really fully implements all of those similar features and allows you to go back as well safely without needing to do manual cleanup. So, number 4. Almost done. I think I only have 5. So, one more scenario. We often see that sort of confounds people when they've moved into a cloud solution. I mean, it's pretty common overall. It's just one of those cases where different environments seem to have dramatically different performance. And I would describe the usual progression of emotional responses. So things look fine on your local machine. Everything's cool. No problem at all. little slower on staging, but it's fine. Like, we can get away with it. And then once you hit prod, like, suddenly it just explodes for apparently no clear reason. You can't really figure out why that is. So I would say this is, when we encounter this is usually a case in favor of deepening your understanding of the database that you're using, even if your ORM is sort of helping you manage that relationship in a healthier way. The chances of your database living in the same rack as your web application in production have basically slimmed down to absolutely nothing, thanks to cloud infrastructure. And so we've suddenly quietly introduced multi-millisecond hops between all these different parts of your application. And possibly you have a distributed database system as well, so that sort of adds to the weight there. Now, if you have a solid staging environment, it sort of represents production. You can notice those additional milliseconds being added. You might decide they don't really hurt you quite yet and choose to go into production. But adding the sudden massive concurrency of your production environment where loads of people are doing the same thing at the same time, suddenly your response times grow exponentially. And I'll describe like one potential combination of things that could be causing this, and it's just something to stay aware of. One really big way that we've needed to change the way that the applications talk to our databases is by relaxing our reliance on transactions. I know we're all about transactions are super important, and they absolutely are. They need to be able to be executed consistently. But we really only should use them when we need them. So when you don't really care about round-trip time in a local development environment, or even like a simple staging environment, you don't notice how often your connector and your database actually talk. And using transactions does exactly what it describes sort of on the tin. Like, you hold a reserved connection, you execute multiple interdependent things in a row sequentially. Every step along the way, you go back and forth, sometimes multiple times. And in the meantime, your database is actively doing something that we call multi-version concurrency control, which essentially comes down to it preserving multiple versions of reality within memory, trying to keep track of what any number of concurrent transactions is trying to do, all the changes that they're making, just in case, like, they might be racing to the finish line, one transaction might undo everything something else did. Like, there's a lot of complexity involved here. And so it is an expensive operation. And it is made worse in every single way by distributed cloud infrastructure. There's no doubt about that. And is it one of those cases where we wholeheartedly recommend making a well-informed decision to relax your transaction consistency requirements, only using them when you really need them? Absolutely. So part of knowing and understanding where your code base talks to the database, and something like that part of things tends to be pretty straightforward when you're using something like Prisma. The other half here is understanding your connector settings. And as Prisma users, I was kind of going through the docs trying to figure out where I could configure that. The connection management doc page is one of the longest pages I've seen. But to me, it's very clear that investing the time and really understanding, like, what are you doing, it tends to pay off big time. So create those connections, understand what's actually reaching your database, how often are you going back and forth. Understand that, change your settings if needed, know how it affects you, and you can dramatically improve performance with just a couple of small configuration tweaks. So just stay aware of that. A last bit of general wisdom, kind of passed down by the product giants that I work with. Nowadays, using a default isolation level of read committed tends to be good enough for more than 90% of workloads out there. So whether you're using PlanetScale or any other relational data store, you'll get more and better concurrency on transactions out of the same number of resources. In short, you're going to save a whole bunch of money and get better performance. So that's what everyone wants. Last anecdote. This one's almost petty to me. It's going to be a quick one. It's another cheap shot at SQL data types, and another reason why whenever someone talks about type safeness at all, I just feel a little triggered. I could do a whole talk about the slowly creeping horror story of realizing that date time types are really lossy. And most people don't realize it when they start to use them. And their precious date fields really are nothing more than glorified, pre-formatted text fields. Like, really, there's no intelligence really embedded in them. And so this kind of stuff really starts shining through when people start thinking outside of their initially deployed cloud regions. So imagine you're wanting to deploy some replicas somewhere else. Suddenly, you're confronted with multiple time zones, and you realize, actually, you cannot compare these values because you don't know what the source time zone is. And so once you start trying to use date time fields for any operation that requires auditing or actually being 100% certain what is the real time you were trying to store, just don't use them. Essentially, I've seen too many systems where multiple years of like weird winter time, summertime changes suddenly have like an hour's worth gap, because that's just what happens. And most people don't even realize it. So I'm not going to say a whole lot more about it. Probably running out of time anyway. So just don't use date times. Just use timestamps, mostly. Any fields you ever want to use for reporting, save yourself the headache, and just store things in UTC. Don't use time zones. Just, pick one and stick with it. So those were my anecdotes. I had a whole spiel about closing this out that was designed around like trying to rally everyone. I mean, it's kind of late in the afternoon. I can see we're not really that energetic anymore. But honestly, most of the talks I've seen here today tell me we're already rallying around the same challenges, and it kind of feels to me like the A-team is already assembled. You know, I'm literally preaching to the choir. So with that said, PlanetScale has summarized our design principles as a part of our feature launch week 3 weeks ago. From our side, as a relational data store, we aim to keep doing whatever we can to keep building that platform that focuses more on what it can do for you instead of just acting as an immovable object in your path. So real quick, because this talk was really all talk. I haven't really demoed anything. But yes, there is actually a real database that has been generally available for 7 months. It's already supported in Prisma, so you can try it right away. We are running workloads that generate up to hundreds of thousands of QPS today. And if you'd like to give it a shot, I can only really recommend you try out Beam. It's an internal company communication platform. We open sourced it as kind of the perfect example use case, and it implements all the things that PlanetScale stands for. And it's built on Prisma as well. So if all goes well on your path and you have learned some things from today, I hope you may never even need to talk to me in the future, but if you do, I look forward to it. And don't hesitate to come up and ask any questions. So thank you very much. Any questions? Or what's that? Yeah, 2 minutes. Anyone awake?
So how do you store date time in a database?
I would recommend using, for anything that doesn't require you specifically storing times before 1970. So anything that you're using standard fields like created at, edited at, the kind of stuff that everyone uses to be able to do reporting on later, use timestamp. Just a timestamp using a UTC basis. It is much cleaner, it consolidates, and yeah, it's much more reliable. In general, it's very easy to transform, and you're not going to end up losing a lot of data.
I have here a little bit of note about this, because if milliseconds are important for you and you're using MS SQL saves 1 fucking byte on that. And you will not say if you want, it has only 3 or 4 fraction at the end for it. So, of course, you will not lose a lot of data, but you will lose something very core for your application. So every time you should really deeply consider what do you do with dates, and there is no silver bullet at all.
Fair enough. Absolutely. I didn't know that, and I fully support your statement. Know what you're using and make sure you understand what's actually being stored.
Liz, thank you so much. That was really a pleasure. And if you haven't tried the branch merging strategy in Planet Scale, it's all the right kind of mind bending. So it was really a pleasure to use. Thank you.
Thank you.